Alright, this video will help you solve a system of linear equations via a method called elimination. Or this is kind of the basics of elimination when the numbers line up nicely. So you notice on the right here we have a system of equations. 3x plus 8y equals 7, negative 3x plus 2y equals 13. All of our variables are lined up nicely. They're in standard form. Our x's and our y's and our constants are all sort of in the same places. And you'll notice that we've got a 3x and a negative 3x, which means step one over here at the left, it says to arrange the equations with like terms in columns. We've already got that handled, and we have that nice relationship between the x's. So now we can do basically the big step, and that's to combine the linear equations. Linear combination is another name for this method. So is the addition method. It's another name for this method. Basically because we're just going to add our two equations together. 3x plus negative 3x is going to be 0x. 8y plus 2y makes 10y. And 7 plus 13 makes 20. So notice we went from two equations by adding them together and eliminating x down to one equation with only one variable. In that case, we can divide by 10. And we end up getting half of our answer. Again, we know that y equals 2. Then, very similar to the substitution method that you may have known from before, once I know one of my two answers, I can plug that number back into an equation. Doesn't matter top equation or bottom one, either way will work. But I'm going to plug y equals 2 in for y and solve for x. So I believe I took the top equation here, 3x plus 8, right, from the top here. Replace the y because we know the answer and set it equal to 7, which means 8 times 2 is 16. You can subtract that 16 to make a negative 9, and again divide by 3 to make negative 3. Now we know our full solution is going to be negative 3, 2. We can also plug those two numbers back into our two equations, and notice in the top equation it'll come out 7 equals 7. In the second equation, negative 3x plus 2y equals 13, it'll come out to 13 equals 13. Because those are both true statements, this is our solution. It's a good answer to our system, or a good solution to our system. And that's the basic elimination method. So let's take a look at one example where elimination gets a little bit trickier, not very much. But you'll notice right away our system up top over here basically is not lined up correctly. We've got a 6x on the left, we've got a y on the right. In the bottom equation, everything's on the left side and only 0 on the right. We've got to clean this up a little bit. So in the first equation, I'm going to keep that 6x where it is, but I'm going to bring that 4y by subtraction over to the left side. So minus 4y is equal to, and leaving that 14 on the right. Then, in the second equation, I want to do the same thing. I want to bring my x and my y on the left side. So again, they're already there. I'm just going to rewrite them. 3x minus 4y. Only I don't want this 1. I want that 1 on the right side over where that constant 14 is. Well, I'd love to have that 1 on the right. So I'm going to move that to the right by subtracting 1 from 0 and moving it over here. We've got our x's, our y's, and our constants all in nice columns. Now the downside is, unlike our other example, if I add right now, I'm not going to be able to eliminate. 6x plus 3x is 9x. And that's not a bad thing. But negative 4y plus another negative 4y is really negative 8y. Well, if I didn't get rid of x and I didn't get rid of y, then there really wasn't any point in eliminating. So we need to do a little bit of extra work before accomplishing that task. Because the two 4's are so alike, if one of them was positive, that'd be very helpful. And we can, using our basic algebra steps, multiply this equation by negative 1. So I'm going to multiply negative 1 times 3. I'm going to multiply negative 1 times negative 4, making that positive 4. And I'm going to multiply negative 1 on the right side, meaning we're going to balance, right? Our equivalent step, negative 1 on the left, multiply by negative 1 on the right. makes for a positive 1. Now if I add my equations, 6 plus negative 3 would be a 3x. Negative 4 plus 4 is 0y. And 14 plus 1 is 15. Now I've eliminated that y value. So now if I divide by 3, very simply, x equals 5. And we have, again, half of our answer. Again, take that 5, we'll plug it back in. Let's go to the equation we didn't really do very much to, that top equation. And we could say that 6 times x, which we know is equal to 5, minus 4y is equal to 14. Which means here 30 minus 4y equals 14. If we subtract our 30, we're going to get a negative 16 on the right. And if we divide by negative 4, that'll make y on the left. And negative 16 divided by negative 4 would be positive 4 on the right. We now have the other half of our answer. And we know that the solution to the system, or if we graph them where those two lines would cross, would be the coordinate 5, 4. And again, we could always take those numbers, plug them back into your equations. I always encourage you to check your answers by resubstituting and making sure both equations would be true if x was 5 and y was 4. Given the choice, again, linear combination is very easy to do as long as you always add your equations together. I discourage you from subtracting. It would have worked. It's kind of like distributing that negative 1. But you tend to make a lot more mistakes doing it that way. So again, highly encourage you, just from my point of view, add those two equations, eliminate a variable, another name for that method, right? The elimination method, and solve for the two variables in that case. Hopefully that's helpful for you. And if you have any other further questions, make sure you talk to your math teacher. Otherwise, good luck, and as always, have fun.